Tabulation in dynamic programming. Tabulation is a fundamental technique used in dynamic programming to solve problems efficiently by breaking them down into smaller subproblems. What do you do in tabulation? You will store the results of expensive function calls in a table, and whenever you want to make the same function call with the same input value, you will reuse the result in the table instead of computing again. This is what you are going to do in tabulation. In the last lecture, we discussed about storage mechanisms that are used in dynamic programming, and there we discussed that there are two major storage mechanisms used in dynamic programming. One is memoization and the other one is tabulation. We also discussed that memoization is a top-down approach and tabulation is a bottom-up approach. In this lecture, we are specifically going to discuss about tabulation. Memoization was used whenever you want recursion, and in this lecture, we'll see that tabulation is used whenever you want iterative solution for a dynamic programming problem. Let us see how this is used. Why is recursion used in memoization? That is, whenever it is top-down. The reason is recursion always works in top-down method. That is, it will start from the top. It will keep making recursive calls till you find all the solutions. This is how it works in recursion, and that is what you did in case of memoization. What about tabulation? In tabulation, you are going to start from the simplest problem and start looping from there. What will you do then? Whenever you solve a problem, be it the simplest of the problem, you will always store the result inside a table. Whenever the same call is happening again at any later point during your iteration, you will simply fetch the result from this table instead of computing again. This is what tabulation is about. So you can say it solves the problem by iteratively filling up a table with results of subproblems. This is what you can say. Keep in mind that recursion always starts from the toughest problem and keeps making recursive calls to the smaller problems. But in case of tabulation, it always starts from the simplest subproblems and then it will slowly build up the solution to reach the original problem. And then one more thing is, why is this called as tabulation? The reason is the word tabulation comes from a Latin word called tabula. This means a table. So what is tabulation? Tabulation is the process of filling out a table so that you can later use these computed values to solve the problem efficiently. What you will do is, we'll go to find an example, and using this example, we'll try to understand what exactly is tabulation and how is tabulation going to provide an improvement over a solution which is not using DP. Let us say we'll take the same example, Fibonacci series example that we used in the last two lectures. How did we find this Fibonacci series? First two numbers will be 0 and 1. After that, for the remaining numbers, what will you do? You will add the previous two numbers in order to get the present Fibonacci number. That is, if you want to find the next Fibonacci number, you will do 0 plus 1, which is 1. How do you find the next one? 1 plus 1 is 2. The next one, 1 plus 2 is 3. The next one, 2 plus 3 is 5, and so on. So in short, you can say Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. That is the sum of previous two numbers. And what about first two? Fibonacci of 0 is 0. Fibonacci of 1 is 1. So this is how you generally find the nth Fibonacci number. Let us try to convert this into a function. Let us convert it into a recursive function using which you can calculate Fibonacci series. So let us say Fibonacci of n. How do you calculate this? If the value of n is less than or equal to 1, that is, if it is Fibonacci of 0 or Fibonacci of 1, what will you do? You will simply return n. because that is what you want to do in case of Fibonacci of 0, which is 0, and Fibonacci of 1 is 1. What about the remaining ones? You will return Fibonacci of n minus 1 plus Fibonacci of n minus 2. This is what you did in case of recursion. And what did we discuss? What is the problem with the solution? The problem is that it will make a lot of repetitive calls. That is, if you have f of 4, you will call f of 3 and f of 2. Again, this f of 3 will call f of 2 and f of 1. This f of 2 will again call f of 1 and f of 0. If you see, there will be a lot of repetitive calls. For example, this f of 2 will again call f of 1 and f of 0. So these repetitive calls will be of the order of 2 power n. Exponential number of repetitive calls will be there, because of which your time complexity will be order of 2 power n. This is the problem with the normal simple recursive call. What can you do with tabulation? Let us see how we are going to bring this down to order of n using tabulation. So let us see, in the previous lecture we saw memoization. Memoization was just a slight improvement on this recursive approach. That is, we use the same recursive approach for memoization, but we simply stored the results whenever it was computed. But in case of tabulation, we are not going to use this recursive approach. So this is not how we are going to solve. Instead, we'll use iteration, where we'll start from the smallest problem, that is f of 0, f of 1 and so on, and then we'll slowly build it up to f of n. Let us see how that is done. So instead of this return function which is going to call all the smaller problems, instead of this, in case of tabulation, we are going to have a recursive call, that is, for here till n is 1, that is 0 and 1, we are going to directly write that f of 0 is 0, f of 1 is 1. For the remaining ones, let us say for I is equal to 2 to n. What are we going to do? We'll have a table. Let us say this is a table. In this table, we are going to fill up all the values and use whenever it is required. So you will say t of I is equal to t of I minus 1 plus t of I minus 2. That is, you will have this table. In this case, you can say it is just an array instead of a table. So this will have all the values from 0, 1, 2, 3, 4, 5 and so on. Here, instead of defining this, initially you will create a table which is, let us say, having n elements. Totally there will be n elements. After that, you will say t of 0 is fixed as 0 and t of 1 is fixed as 1. What will happen then? T of 0 is fixed as 0, t of 1 is fixed as 1. This is your array which you will call as table. In this table, for finding the remaining numbers, you are going to use t of I minus 1 and t of I minus 2. That is, the previous two numbers will be used in order to find the next Fibonacci number. So how will you find t of 2? In order to find t of 2, you will do t of I minus 1, which is t of 1, and t of I minus 2, which is t of 0, which will help you find out 0 plus 1 is 1. So this will be 1. How will you find t of 3? In this loop, you will do t of I minus 1 plus t of I minus 2, which is 1 plus 1, that is 2. Which is the next one? Next one is 1 plus 2, 1 plus 2, which is 3. Next one is 2 plus 3, which is 8. 2 plus 3, which is 5. So in this way, you will keep filling this array and find out the nth Fibonacci number. What will you do finally? You will return t of n, whichever is the nth Fibonacci number, that will be returned. This is the tabulation approach. So what are the advantages of this tabulation approach over memoization? Over normal recursion, we already know it has a lot of advantages and it is a substantial advantage, because from order of 2 power n, you brought the time complexity down to order of n. So this is a substantial advantage, and this is therefore memoization as well as tabulation. The next question is, what exactly is the advantage of tabulation over memoization? That is what we want to know. So that advantage is, We know both in case of memoization as well as tabulation, you have to store all the result of function calls. But in case of memoization, there is additional overhead due to recursion. There is recursive call going on. So whenever you call recursive function again and again, what happens? You will be adding new entries to your recursion stack. This means extra memory, extra overhead is used for recursive calls more over this table. In case of recursion, that is memoization, you had a table, you had a memo in which you are storing everything. Over and above that, you were having additional memory used for recursive stack. This time, because you are using iterative approach, there is no additional recursion stack that is required, and you are saving the space that you are using for recursion stack. That automatically means it is space efficient and time efficient. How is it time efficient? Because it is easier to make a simple calculation than to make a recursive call. So this is how it is making both space and time wise added efficiency to your algorithm. So tabulation is in some ways better than memoization when you are thinking in this way. The other side of the coin is writing a recursive formula, a recurrence relation is normally easier than writing a iterative one. That is especially for complex problems. Why is it? Because recursion many times looks very logical and it will be easier to write it down because you're writing the larger problem simply as a part of smaller problems. So writing that is easier. When you're simply writing a larger problem in terms of smaller problems, that is a easier way to write an algorithm. Coming to the iterative algorithm, you have to think more about it and start solving the problem from the smallest one and slowly build it up till you reach the largest. So this is considerably tougher to write, but it is space and time efficient when you compare with memoization. So one more thing is that space used here is predictable. You already know and you have decided that this is the table I am going to use, and you know this is the total additional space that you need. But in case of memoization, you are not in complete control of the recursive calls. So recursive calls will keep increasing and that will take up memory. In this case, the table, it is very conclusive. You know beforehand that this exactly is the table that is used. So this is it about tabulation in dynamic programming.